First off, I'd like to say happy Memorial Day to everyone and honor to those who fought and served and fell for all of us so that we could keep doing what we're doing here in America. And with that being said, I think I figured out the power problem here. Now, these batteries could technically push 480 amps without any issues. So, I could use a power distribution board. And I figure why not 2 bus bars, but I was designing a PDV in Fusion on the electronics tab, and the pores for the amps that I'm pushing would have been the same on the traces than just getting bus bars and using those. Now, we could use bus bars and run 2 batteries, or we could eliminate the bus bars and all that extra altogether, but we would add more weight if we just decided to go with 18 cell packs for each individual ESC and then run the signal wires to the flight controller. So, I think that it's possible just to go ahead for testing purposes to run a bus bar and then the 10,000 milliamps, not that one, obviously we need one more of these, in series, obviously, for the 18S. And we'll use the bus bars and run the ESCs to the bus bars. But ultimately, that's just for testing. There's going to be a hydrogen fuel system component going into the actual drone on completion. So things will change in the power system a little bit, but that's where we're at right now. So I did the math. Yes, this can calculate, or this can put out basically 1,200 amps max current draw without damaging the battery, because you have to take 10,000 or 10 amps times the 120C discharge rate at 48 volts, so on and so forth. You do the math. And it shouldn't cause any battery swelling, running 4 motors at 400 amps with a peak overhead of 480. So bus bars, batteries, ESCs, I think it's probably going to be the cheapest way to go. Otherwise, I got to spend like almost $1,000 on more of these batteries. So bus bars it is. So, all right, we're getting there. Getting everything together. Be quiet, Finley. Anybody want a chihuahua?